Thank you so much for that introduction. It is my honor and pleasure to be here with you today, and I'd like to talk to you about making data science useful. Now, you'd think data science should be useful just on its own. What is this making thing? And I'm going to tell you that I have 10 tips for you. You'll notice that they are all to do with organizational culture, people things. In my experience, data science isn't useful on its own unless we approach it the right way, unless we really take the human aspects seriously, and unless we approach leadership in data science properly. So let's go through 10 tips, starting with the first one. What on earth is data science? Let's make sure that we agree what we're talking about, because data science means different things to different people. And according to some people, it's the science of everything to do with data, and then what is data? It's all information. And then it sort of begins to sound like data science is the science of everything, and well, that just seems like we're trying to capture all the other sciences. So instead, I propose to you a breakdown of data science into 3 constituent disciplines. So data science is an umbrella term for these 3 disciplines. And here we have descriptive analytics, machine learning, and statistical inference. But how do you taxonomize those within data science? Now, some people might think it's by the tools used. I hope those of you who are practicing data scientists, you are appalled by this breakdown, because it is utterly horrible. I shouldn't even have it up here, because in each of these tools, you can do any of them. And the tools are becoming better and better, enabling more and more crossover. So, terrible breakdown. Let's try another one. To some of you, the difference between these 3 fields might have to do with methods or algorithms used in them. So you might want to break it down this way. This is also a terrible breakdown, because if you are a cunning data scientist and you have a point to prove, you can use any math for any of them. So I propose instead this breakdown. Where am I pointing? I'm aiming it in the wrong place. Ah, there we go. It's somewhere here. We can find it. We've been playing hot and cold there. So I propose this breakdown: none, many, and few. So what do you think? None, many, and few what? This one time I asked an audience this, and they said, is it data points? I said, wait, hang on a second. It's pretty hard to do analytics when you have no data points. So it's definitely not about how much data you have. Instead, it is about the decisions that you want to make in advance, what your goal is here. And this is also why I have the title of Chief Decision Scientist. To me, applied data science is all about making decisions. When we do descriptive analytics, our goal is to look at what is here in these data. We don't know in advance what decisions we want to make. We're dealing with the unknown unknowns, and we're making them known. We're having a look at what is here. When we are in statistical inference, we are making one or a few very important decisions under uncertainty. So we know in advance what we're choosing between, and we are using the data to help us make that decision carefully. And when we want to make a recipe for automated decision-making, many decisions over and over, using a model, then we will go to machine learning or artificial intelligence. And by the way, artificial intelligence, as the term is used today, it tends to refer to a subset of machine learning that uses a particular class of algorithms, deep neural networks, deep learning. So more technically, what business is getting excited about when they say artificial intelligence, the technical term for that would be deep learning. But you know, at some point you have to give up on being excessively technical, because business runs off with the language that they want to. A language evolves. So now when we talk about AI, it does tend to mean machine learning with a specific class of algorithms. And here's the good news for those who are sweating over, do I need to know the difference between machine learning and AI? In practice, when you're applying it, You don't have to know in advance whether your application requires that algorithm type, because you know what you're going to do in practice? You're going to try a whole bunch of available algorithms, and whichever one seems to be working best, that's the one that you're going to iterate on. So you start the same way regardless. And machine learning and AI is for making many decisions. So again, descriptive analytics, that's where we're getting inspired with data. Statistical inference, that's where we are deciding wisely under uncertainty. And machine learning and AI is all about automating decision making. And so because it has this decision making aspect to it, you see that it matters what our decision goals are, and therefore it matters who is setting those goals. This boils down to a human thing as well. Who is the leader here, or leadership team, committee, and what do they want to do with their data or information? And that's where it has to start. All of this stuff starts with what do the humans want to achieve with their data? Okay, tip number 2. If you're going to go into machine learning or AI, it's worth knowing which business you're in. So I have a very serious question for all of you here. Who here knows how a microwave oven works well enough to build a brand new one from scratch? Any hands? Do I see any? I see 2 hands. This is incredible. Wow, okay. I'm outclassed because I have no idea how one of these things works. Different question for you. Who here has never used a microwave oven to heat food? Okay, again, I see maybe 4 hands. Diversity is good in an audience, so we have some non-microwave users. It's a diversity conference, that's excellent. It's totally in the spirit of the thing. Now, what I want to point out here is that if we subtract these 6 people from our, what do we have? I was told 700 of you. I'm left with a very large group who, 1, uses microwaves, and 2, has no idea how they work. How interesting. Why do you trust those things? You've never read their blueprints. You don't trust them because you read how they work and you understand the physics. You trust them because you think about what you need them to do for you, and then you check whether they deliver on that. You put some food in there, you expect it to get warm, and if it comes out burnt or it comes out cold, then you throw away your microwave and you get a different one, yes? Right. That's also what you're going to do with machine learning and AI. You're going to get your microwave, you're going to put some ingredients or data in there, and then you're going to taste what comes out. You're going to make sure that it is what you wanted, and if you don't like what happened there, you go and you get a different microwave. Now, my microwave here is an analogy, and it's an analogy for the machine learning algorithms that you're going to use. Those fancy things with names like neural networks, or decision trees, or linear regression, or support vector machines, or what have you. Those fancy things. And this is a bit of a warning, because when we say machine learning or AI, we make it sound like it's just one discipline. But actually, there are several disciplines going on here. Machine learning research is the one that most courses, machine learning and AI research, is the one that most of the university courses are actually about. That is the one that teaches you how to build new and better microwaves. And you need quite a lot of education to build a better algorithm than the one that already exists, right? Think about microwaves. How are you going to build a better microwave than this one if you don't know how this one works? So, of course, you need all those years of study, if that's your goal, because there is a huge history of these things. I mean, take linear regression, which is a standard and commonly used machine learning approach today. That thing, I think, dates back to 1805, so it's more than 200 years old. These things have been around for a long time, and so if you want to create something better than what has been made over 200 years, you need to catch up on that large history. So of course you need all that study if your goal is to make new and better microwaves. But not everyone wants that. Some people just want to get cooking already. They want to solve real business problems. They want to innovate, not in microwaves, but in recipes. They want to go tinker, dabble, play in the kitchen, and figure out how to make a, I don't know what, gluten-free croissant, let's say. That is a different game from innovating in appliances. You need different skills for that, especially when it happens at scale. And what I see a lot of businesses doing these days is they decide to open a massive kitchen, right? Industrial scale, McDonald's size operation. They want to innovate in recipes. They want to serve dishes. And you know who they hire? A team full of carbon copies of the equivalent of people who have been building microwave components their whole lives. Right? To run a kitchen, to figure out how to make gluten-free croissants. What could possibly go wrong, right? And if it doesn't go wrong, don't pat yourselves on the back for excellent leadership and planning here. That's you getting lucky. You hired a bunch of microwave engineers who just so happened to be passionate about cooking, who just so happened to be great chefs. And then by accident, they went and taught themselves this other discipline of how to apply these algorithms to ingredients to make new recipes. These are completely different fields. And in fact, this isn't, it's not only two disciplines here, there's a whole bunch of different disciplines related to data science and machine learning. So one of these disciplines is data engineering, getting the ingredients. And as in my kitchen analogy, it's very easy to go grocery shopping when you're just cooking something for you in the kitchen. But when you increase the scale to, say, McDonald's scale, think about the logistics and distribution of those ingredients and preparing them at scale. Think about getting 20 tons of ice cream and delivering that all so it doesn't melt. That's the kind of trickiness that we're talking about with data engineering. Yeah, sure, when it's small, fetching data is like fetching a spreadsheet and opening it. When it's big, it's a sophisticated discipline in its own right. Then we have, as we move to the right, we have the machine learning research. That is about making new kinds of wiring diagrams, new algorithm blueprints that enable appliances that solve new kinds of tasks. Say you want to make teleportation soup. The soup must be teleported directly into the plate. Well, then you'd better hire a researcher who studies teleportation to help you make a teleporter for your massive kitchen. That's a research problem. And the researchers, those are the folks that we're training, who do that stuff. We're not really training the folks who just, use microwaves at scale. But you know what happens when they make that blueprint? Like, imagine the first microwave. It's a prototype. It works, sort of. But it's probably held together by sticky tape and hope in the lab of the researchers who made it. It is not going to be user-friendly for everyone else to pick up off the shelf and use. And probably if you slam the door too hard, the buttons fall off. So here in the bottom left is a different job, the tool makers. And Google Cloud is one of these, but there are a whole lot of folks in the open source community who do this as well. That is, take that research, those blueprints, and make nice, robust, user-friendly microwaves that don't make you want to cry when you use them, so that you can put your ingredients in and get stuff out on the other side. So that's another group of people working in this data science community. Then, on the bottom right, the recipe makers, the applied data scientists. You have a business goal of making that gluten-free croissant? How do we actually figure this out at scale? How do we make that recipe? And then, finally, we have some businesses who don't care about the innovation parts. They just want to serve those dishes, that pizza or that croissant. And so they are in the business of making sure that they have gotten together everything They have bought ingredients, they have bought recipes or models. Now they want to make sure that they simply serve their customers what their customers need. And when I say simply, I say that tongue-in-cheek, because you want to open a regular pizza business? You're going to take existing recipes, you're going to take ingredients known to humankind, but you want to do that at scale? It's not easy. So this is what we're dealing with the business of data science. And then tip number 3. This is a bit of a warning, but it's also a happy thing. But it's a warning in terms of data science career. There is a lot of amazing strutting about how hardcore certain machine learning or AI engineering types feel about what they know about their skills. I just want to warn you. See that thing on the right there? Who recognizes what that is? Yeah, I get a few hands. That's a punch card. There, once upon a time, people were proud of knowing how to use those things. How about today? We don't need to do that anymore. So that knowledge is no longer useful or marketable. But I bet once upon a time, there were people strutting, saying to their college roommates, hey, you don't know how to use a punch card, so you suck. There's a lot of that today. I'm sure there's people saying, you don't know how to use TensorFlow. So what kind of data scientist are you? Watch out, because the tools are getting better. Right now, a lot of what's hard is that all we have to work with are either blueprints in research papers or microwaves that have their doors falling off because the super glue is not working. But because this is super useful stuff, making recipes to automate tasks with data, because it's useful, the tool makers making these microwaves available to everyone are making better and better, more and more user-friendly tools where you just have to put the ingredients in and get something out on the other side and have a taste. So that part about how to actually use the microwave, I personally don't believe that that is going to be the most important skill in data science over the next few decades. Right now, there's a lot of strutting about it. But I just want to warn folks, don't overinvest in that too much. Maybe invest in, if you want to strut, show me how user-friendly you can make those tools that you understand. You're so proud of how you've read all those blueprints and you know all that researchy stuff? Cool. Why don't you make a package that a 5-year-old can use to put in images and get out a classification of what Lego piece is out on is shown in the photograph, right? Why not make a tool that's so easy that a 5-year-old can use it? If you're so proud, that's my challenge to you. Make an easy, user-friendly version of that. And as for everyone else, the key skills are going to be around the leadership and creativity stuff. What do we want to make with data? What problems do we want to solve? And how do we arrange a team to go about and get it done? All right, next tip. I'm a recovering statistician. And yeah, getting real personal here. As a recovering statistician who now is surrounded by a lot of machine learning folks, I'm constantly amazed at some of the naming here. For example, we statisticians, we like things to be named exactly what it does. So if we had named machine learning, you know what we would have named it? The labeling of stuff with data. But then, of course, you see that's maybe why we lost the patent on that thing, and it's now its own discipline and not part of statistics, because I guess we've always sucked a little at the marketing. Or neural networks. Let's say neural networks. Do you know how little those things have to do with the brain? They were named in the 50s. We didn't know how the brain works then. I have a graduate degree in neuroscience in addition to my statistics one. We still don't know how the brain works. And yet, look at the goal of this thing. It's named neural networks. All it is layers upon layers of mathematical transformations with a bit of nonlinearity added in there. You know what I would prefer for us to name it so it doesn't sound so intimidating? How about yoga networks? Because their special skill is that they're really flexible. They give you a nice flexible and sometimes too flexible boundary through your data. So let's name them after the flexibility. Call them yoga networks. Except there again, maybe it loses some of the marketing, some of the robot-esque stuff. There's a lot of proof by intimidation here. And I think that people who don't feel good about approaching a thing that sounds like it's fancy or sci-fi that they don't have a full grasp of, they stay out. Whereas the people who are quite happy to continue perpetuating this stuff and talk things up and speak about them as if it's something more than what it actually is, maybe they find their ways into the discipline. I don't know what diversity consequences that has. I will leave that to your imagination. But I do think that we are at a point where maybe we have let this run away with us a little bit. The language is too science fiction-y. Now, what I will say is that AI, named in the 60s, has been around for a little while, but for the longest time, you couldn't do anything useful with it. The reason it's so hot right now and the reason that it's useful today is that it requires a lot of data and a lot of computing power to make it go, and now we've got that so we can do cool stuff with it. But for most of last century, it was all talk. So how do you get funding if it's all talk? Of course you make the appeal to the science fiction. I get it. But why don't we recognize that today it is useful? And we can make an appeal to the usefulness instead of the fluff. Let's stop with this gratuitous anthropomorphization. These things are not about robots. And if you want to talk about building human-like intelligences, then why don't you use the term HLI to refer to that, human-like intelligence? So most of the AI out there today is just about labeling stuff. Hilary Mason, who is a female data scientist who's a hero of mine, today talks a lot about making data science boring. Let's make data science boring. The people who should stay are the people who like the usefulness of it. And you know how useful it is? Very. So let's focus on the usefulness rather than the fancy names, and let's stop this proof by intimidation. Now, next tip. It's a team sport. I want to point out that data is just information. And information is our constant experience as humans. Now, the thing about us humans is that unlike machines, we get bored as we start reading that spreadsheet. So if I ask you to read a spreadsheet with 1 million rows in it, first you will say no, and second, if you do actually read it, because I tie you down and force you to, by the time you get to the 1,000,000th row, you've forgotten the first one. That's human memory. Now, great thing is first, we have writing, so we can write things down. But when you write things down with a pen and paper, it's not very easy to search and move around in that information. It's very hard to say, give me the sum of the 3rd row, the 300th row, and the 3000th row. You have to go slowly and find that. But if you put that in a computer, and you have some easy tools, you get the answer just like that. So data, it's just information that's stored in a way that's easy to work with. But it is stored by humans, and it is used by humans. And here's the fun thing about us humans. We're surrounded by reality, but what we notice and pay attention to in reality is just a small fraction. And what we bother to record from that reality is even smaller. So when you start thinking about data as objective truth, I want to remind you that it's some human who chose to pay attention to some very small part of their experience. And then they wrote it down so they didn't have to memorize it. That second part, that's the power of data. It's a memory extension. We're all cyborgs because we don't have to remember stuff. We can look it up in Wikipedia or in the dataset or wherever. But still, that stuff, it is not all of objective reality. It is fundamentally subjective. So, a diversity of perspectives matters because when we think about solving tasks with data, if we have a team that's all carbon copies of one another, they are paying attention to only one small slice of reality, and they're not that creative together if they're all the same. They're missing so much of what might be worth capturing, what might be helpful, what might make humanity better and happier. And so if you increase the broadness of perspectives that deal with this data, you pay attention to a lot more of it. You'll make fewer mistakes. You'll get better outcomes. So diversity of perspectives really matters here. And then there's another part. When we want to apply data science to solving business problems, think about the kitchen analogy. If you get 20 or 200 copies of the same microwave component builder, they're not going to do very well at running that kitchen. You need different types of workers. You need the leaders who say what we want to feed to the customers. You need the statisticians who conduct the taste test. Is it actually good enough to serve to our customers? You need the data engineers who bring us those ingredients. You need the engineers and user experience folks who make and set up the kitchen and the appliances. You also need the user experience aspects of what dishes are we serving and how does that fit into our menu? You need the ethics folks, the philosophers, who ask, is this actually an okay dish to want to be serving humanity? You need the algorithms builders to design the kind of microwave that might solve your problem. And of course you need the applied AI engineers who are going to run around and put those ingredients into the various appliances. Then you need the analysts who, you can think of analytics as you've got all this choice of ingredients, you've got a huge dark warehouse. Which ingredients do you put into which appliances in which order? Where do you start? Well, you can just start taking in the dark a few first things off the shelf, or you can take the person with the flashlight, the analyst, who can run quickly through the warehouse and go, that over there looks promising, and that over there, and that over there, and brings that all with the data engineer back to the kitchen so that you can try tinkering and playing and iterating on your recipe. Then, of course, you need the managers who lead such a diverse team. And I have left out a whole lot of other roles. So perspectives diversity is really important here, as is skills diversity. And what we can't have is this intimidation around, you don't know the backpropagation algorithm, so stay out. You're not a real AI person. What nonsense. You take those real AI people, who, by the way, are a lot like the punch card folks, because when your tools all have that backpropagation algorithm nicely implemented so you don't have to deal with it, then like, what's that skill even for in the applied setting? If that's all you have in your kitchen, you're not going to make anything good. So let's stop this bullying, who's real here and who isn't. Data science is a science of information. We as humans all deal with information. We all have something to say, to contribute to this process. Now, maybe we need some creativity in finding our fit in this kitchen, but I assure you, everyone here today has something to contribute, has a place in data science, whether you think of yourself as a practicing data scientist or not. Think of yourselves as practicing data scientists from now on. Look at you taking in this information from my speech. Okay, what's next? This is one of my favorites. So quite often when I go to leadership conferences in data science, folks will come and talk to me afterwards. And they will say things like, I was hired by company whatever to be their first data scientist. And I said, oh great, how's that going? Well, we have no data. So I never know whether to laugh or to cry when this happens. Companies, what are you thinking? Okay. What happens when that happens? What happens is a bright data scientist with some leadership skills is put into a very difficult position. Either leave this fancy job with this high title as director of or VP of or chief whatever of data science, or learn how to do a different job from the job that you were trained to do and build a team first that does a different thing. And that different thing is data engineering. Data engineering is about the delivery of the ingredients in the first place. And so if a company doesn't have any data and it doesn't have any data engineers, any means of getting data, when you hire a data scientist, that person has to say, okay, I guess I'll put my data science career on hold for 3 years, and I'll build you a data engineering team. These are two different disciplines. This happens all the time, right? It's pretty crazy. So, 2 pieces of advice. First for the offenders, and then for the victims. Offenders. Companies, business leaders. If you don't have data engineering, hire data engineers first. Very nice. Then for the victims. Ask whether there is data before you take that job. And if you do not wish to be a data engineering leader, and the company has said there is no data, this is not the job for you. Okay. Because, especially in machine learning and AI, here's how I want you to think about data. It is textbooks for your student to learn from. Learning can't happen without data. And those textbooks, by the way, textbooks are made by human authors. We had a note about bias in this morning's address. The human decides which examples are in the textbook, yes? And if that human has some skewed perspectives about the world, they will put some skewed examples in the textbooks. And here's the thing about math algorithms. They don't have this diversity of experience that you might have by going out and doing something other than your job, by just living in the world and getting all kinds of different information as a human. Those algorithms, you know what they will learn? Only what you show them. So you feed them some stupid textbooks, what comes out? Some stupid results, some stupid recipes, some stupid decisions, and some stupid impressions. Garbage in, garbage out. So not only do you need data to get anything done in data science, you need good data and relevant data. I tell Google engineers, if they're going anywhere near machine learning or data science, I want them to tattoo the following sentence on themselves. So far, no tattoos have happened, but it's my recommendation. Like, write it on your forehead in mirror script every morning before going to work. And here's the sentence. The world represented by your data is the only world you're going to succeed in. So, if you have no data, you know what world you're going to succeed in? No world. And if your data doesn't represent reality, your models are going to be correct in a cartoon world, not this one. So, what are we doing here if our textbooks suck? Nothing. Start with data engineering. And if you are a data scientist or data science leader in a company with data engineering, a little cultural thing, data science is the client to data engineering. They are the customer. If these two organizations don't talk to one another, and the data engineers have some strange ideas in isolation about what they'd like to do with data, like curate it if they're librarians essentially, and they tell the data scientists to back off. There's some serious organizational problems here. There needs to be more direct collaboration. And of course, data science has to give direct feedback to data engineering. We are the customers, here's what we want. Give us what we want as customers. That makes sense, but I see that not happening quite often. Okay, next thing. Inspiration is cheap, but rigor is expensive. What I see a lot is companies hiring a bunch of PhD folks. And these PhD folks beating their chests and telling everyone, stay away from the data. You are not qualified to touch it. You don't have a PhD and thus and so. Okay. Here's the thing. You know what all of us humans do? We process information, we look at it. That is data analytics. We can look at a scene and describe, this is what is here. Everyone is qualified to do that. And depending on how good the tools are, maybe it is easy to open the information, maybe it isn't. But once you get it open, everyone is qualified to have a look and report what is here, to get inspired. So everyone in the company should be allowed to participate in this, encouraged to participate in this. We don't even know what questions we want to ask until someone has a look at what we've got right here. So enough of this, you need a PhD or you need special knowledge about math or algorithms to get into data. Everyone is an analyst. The best analysts are the ones who are fast at doing this on large data sets. But you know what? I'd rather have 100 beginner analysts than one totally awesome one. They'll probably cover more of my data than one hero can. So let's invite everyone to participate. But here's the thing. When we want to leap beyond what we know and what we can see and deal with uncertainty, that is an Icarus-like leap. Why do we expect that to be easy? Why do we expect that just because we put a whole bunch of effort in and we use all those methods from Stat 101, that reality owes us something? That it owes us a perfect result, or a working model, or a great decision outcome. Reality doesn't owe us anything. We're jumping from what's known, what is here, that's what analytics deals with, to what is unknown. That's hard. That should be hard. And that is the part that we need expertise for. But that's not always what you need or want in a company. Sometimes you just want to see what's here. So let's stop being confused about what the qualifications are to get into this stuff. If you want to deal with what's beyond your data, sure, expertise is important, and quite often things won't work out there. That's what it means to deal with uncertainty. When you want to stick to what's here, everyone should be participating. We're all doing it every day just by using our senses. Now, here's something that you learn in a statistics class. And then you promptly forget it when you go into data science. It would be better if you didn't. It's this. A data point can be used for inspiration or rigor, but not both. So you must choose inspiration or rigor. And my example with this is a slice of toast. You might look at a slice of toast, and you might notice that it vaguely looks like the Mona Lisa. That's cool. That's your human perception finding patterns. You're really good at that. And the thing is, this particular piece of toast, it might look Mona Lisa-ish. And a valid statement would be, this piece of toast right here looks Mona Lisa-ish. Valid. And that's descriptive analytics. That's sticking to what's in the data. Now here comes your mistake. You are inspired by this Mona Lisa to wonder whether bread always looks like Mona Lisa. Good, you're inspired. So far, so good. And then some wires get crossed because you leave common sense and you go to mathematics. And you think, if I just do a little statistical test on this same piece of toast, I can get my answer about whether all toasts look like Mona Lisa. And you know what your algorithm's going to say? Strong Mona Lisa pattern. Yes, all toasts look like Mona Lisa. Okay, big problem. Do you know what you need in order to check whether toasts beyond this one look like Mona Lisa? New toast that you haven't seen before, that hasn't inspired you with this pattern. Because if you've already seen that the pattern is there, all the statistical methods are asking is the pattern strong? In fact, the statement of what statistical hypothesis testing says is this pattern surprising? Folks, if you've already seen the pattern, it's not surprising. It would only be surprising if you haven't seen it yet. So you need fresh data in order to check whether your impression holds water. You cannot use the same piece of toast. So your option is either to come up with your question beforehand, then look at that piece of toast, and you hope you ask the right question, or forget the rigor, just have a look, describe what's in this piece of toast, that's it. But there is a way that you can have both. It's an amazing thing. It is the best invention since sliced bread, I think. And that is splitting your data. In fact, I want to propose to you that the entire history of data science is a history of data splitting. So here we go. Humanity begins with no data sets. Yay. How do you form an impression if you have no data sets? Nowhere. It comes from nowhere. How do you check if your opinion is any good? You don't. Yay, all kinds of subjective nonsense opinions. Then we discover writing, that's cool. And then we go one further and we write things down in an orderly manner. And there we have a data set. Nice, one data set. Now, because we have one data set and we only have enough data for one data set, we cannot split this into two separate data sets, we must choose. Either we use it for inspiration, we have a look at what's in these data, but that's like finding Mona Lisa in a piece of toast. We can't take our opinion seriously, but there we go, we've got an opinion. Or don't look at the data yet. Carefully think first, meditate in a closet, think about what question you would like to ask these data, and then one time and one time only, open that data set and get a rigorous answer as to whether your opinion holds water. And that is statistical inference. One or the other, that was your choice when you had one data set. And I want to point something out. If you only have one data set, you must choose. You cannot have both. And then, in the times that we only have enough data for one, there are certain industries that today will still tend to have data sets that aren't large enough to turn into two, for example, medical research. In those industries, you must choose, and then you get this splitting of culture. This is interesting. You get the analysts who give up on rigor, but they still want to feel good about what they do, so they might pretend that they do something that's a little more rigorous than what they're actually doing. I frown on this, because what's going on there is just having a look at what's here and finding as many patterns as possible. Are they any good? Who knows? We're using that same part of our brain that finds the Mona Lisa in a piece of toast. Please, folks, be humble. Don't take yourselves too seriously, but have a look at what is here. Just don't overreach beyond the data. And then we have, but this is now a culture of enjoying yourself, opening a data set, being as sloppy with it as you like, getting as inspired as possible. And then we get a different culture that is the statisticians, and this is where I grew up, the camp I grew up in. These are the folks who are always shouting at you to be careful. Do not look at the data. use it one time only. And if you're going to use it multiple times, then do multiple comparisons, correction, and all kinds of stuff like that. Meditate in a closet first, open it one time, and they're super careful. And they tend to say amazing things, amazingly nasty things to analysts. In fact, I was on an email chain recently, as appalled to see this. I was asking about an analytics tool. There were statisticians on this email thread. And one of the statisticians wrote, "I hope a tool like this doesn't exist, because it would invite misuse." This sounds like statisticians, right? A tool that allows you to look at your data a whole lot, that's no good, because that's the opposite of meditating in a closet, coming up with your one question, and then getting that careful question answered right. But here's the thing. How do you know it's the right question? It's pretty hard to get inspired in a closet and ask the right question. All of this is, for many industries today, such horrible, old-fashioned nonsense. Because today, we can get enough data for 2 data sets. And you know what we do then? We just simply split the data into 2 data sets. You got 2 pieces of toast. Instead of looking at both of them, look at one of them, do analytics on it to get inspired about the questions you want to ask, and then answer them with the other piece of toast. Job done. You can have both. Both the analytics, the inspiration, and the statistics, the rigor. And you don't need to have this cultural fight between the two. And yet still, you have people trained as analysts and you have people trained as statisticians and you hire them and they don't get along. There is a solution. It's called the 21st century. Just split your data. But in order to satisfy these requirements, you need to be in the habit of splitting your data, which is why this is my favorite idea. Always split your data at the beginning. And here's the other thing. We have too much of this look at the data, slice it from every angle you like first, and then just show the rigorous version that proves your point on the same data set where you do a fishing expedition. Why would anyone today trust someone who takes that approach? And then, you know what they do? They argue the math and the methods as a basis for what they're talking about. You know what? I tend to ignore that all as noise. Sorry to those of you who do your science like that. And I say, fine, if you've got some opinion, why don't we see how it works on data that you haven't looked at yet? Because if you know what you're talking about, then you should be able to predict what these data that you haven't been able to tamper with will do. That's the best basis for trust in business as well. Not what algorithm sliced what in what way, but here's some stuff that we didn't know anything about. We have some theory, wherever it came from. Does it actually work there? So this splitting actually applies to a whole lot more than just data science. And it is a privilege of having a lot of data. But wait, there's still one more aspect. Where does the inspiration come from? In statistics, that rigorous approach, it requires you to use your data set only one time, or if you're going to use it multiple times, you need to pre-plan every test. So when you decide to go to testing, that statistical part, that data set gets used up. So before any sensible leader approves of that testing procedure that burns through their precious testing data set that lets them know if their opinion is nonsense or not, they're going to want to know the credentials of the human, the analyst, who came up with the inspiration. You're going to prefer the experienced analyst who knows a little bit about your context to the intern that's just wandered onto the scene. Yes, you've got the privilege of checking whether or not the thing works, but it still kind of matters who got you the inspiration. And so you're going to trust a seasoned human, and you know what you're not going to trust? Just some algorithm that does some stuff to some data. Unless you have 3 datasets. If you have 3 datasets, if you can split your inspirational one into 2 pieces, you get a little interim test drive where you don't end up burning your final dataset on some piece of inspiration, where you get to check in the middle, is this actually worth using my precious data for? So now everyone can have a go. The intern, the seasoned analyst, the tea leaves, the stars, everyone can help form the initial model. Then we check if any of them seem to be working on a middle dataset, and then we go finally to testing. That is the essence of what machine learning is. A whole lot of automated inspiration in the beginning, haphazardly, where you can bounce it back in the middle. You don't have to blow your final dataset on it, where you can try things out and iterate a whole lot, multiple tries at coming up with a solution. So if you want to know what machine learning actually is, because it is the same math and the same algorithms, machine learning boils down to the privilege of having 3 datasets. You have data to burn. 2 initial datasets before you have to check whether your final model works on new ingredients. But today, we go one step further. We use 4 datasets. We, in exploration, have a refinement step as well. Because what that validation or middle dataset lets us do is it lets us have a performance check, but we don't get to do any debugging inside. We just get to see how well we're doing. And that's how we avoid training too much on the validation data, but we still want to have some direction of what to do next when things don't work. And so we use a 4th dataset to go and debug inside and look at individual failures and figure out what to do next. And this might be a little technical for those of you who aren't practicing data scientists, but because I like data splitting so much, my one technical piece of advice for you is 4 datasets, not 3, not 2, not 1, if you can afford it. This is the privilege of having a lot of data. Also, a note here is, if you don't have much data, can you do AI? Nope. And what is transfer learning, by the way? Transfer learning, people make it sound like it's doing AI with no data or with very little data. That is not what it is. Transfer learning is where you get to use the results of someone else's data as a starting point for your own project, so you need very little of your own. That is a different thing. Still needs a lot of data, it's just that you're borrowing someone else's. So AI only works when you have a lot of data. Then, last things, and I'm going to be quick so I can give back the floor. This business of leaders saying to me, and I hear this all the time from senior leadership, data science is useless. Well, here's why it's useless. You hire a bunch of microwave builders, you put them all in a room together, and you tell them to go be useful. When you hire these folks and you get them out of academia and they have PhDs, they're going to do, most likely, what is in their comfort zone. Now, I want to remind you, and I might be making fun of a few folks here who are in academia, so I apologize, I was there as well. But let's remind ourselves what the reward is. You know, the creatures respond to incentives and rewards, yes, and they might stick around in an environment that gets them a lot of rewards. Now let's think about what academia is in that sense. In academia, you get a reward, a pat on the head, a gold star, every time you do the most complicated thing you know how to do. Am I wrong? The most sophisticated thing in your arsenal. Not necessarily the most useful thing, but rather the most impressively complicated thing. And so then in industry, when you leave academia and you're put in a room with a whole bunch of other academic type folks, and you're not asked to do research, you're asked to do useful data science, you're not going to want to take the solution that adds the number 1 plus number 2 and, you know, makes $100 million. Because how are you going to write a paper about that? So there is a tendency for academically trained data scientists to do things that are complicated. That's their comfort zone, rather than focus on impact and usefulness. The problem is the leadership. You can't expect folks to just naturally transcend and do something else. Instead, here is my piece of advice for leaders. Rigor must start with you. Shut down the ability of data scientists to do complicated things on their own. No longer allowed. Instead, ask everyone to engage in analytics, looking at data, and bring those results to the business leader. And if the business leader sees something in those inspirational results that triggers a reaction, this is important for the business. This is worth pursuing rigorously. This is worth doing something complicated with. Then they make that request explicitly to the data science team. So they decide what to pursue rigorously, rather than just allowing this process of it's interesting to do something complicated for no good reason. So that is a split then, also an intentional split, between inspiration and rigor. Inspiration all the time, and if the decision maker sees something in that inspiration, go rigorous on it. That directs that beautiful, potent skill of the academically trained data scientist in the direction that is good for business. And then finally, I'm going to zoom through one last thing. A quick tour of the different kinds of data professionals and how you should think about what they are in terms of the data split. So up above the toy data, that's simulated data or data sets that are used as benchmark data sets, that's in gray. All the data is in orange. That bluish one on the right is the inspiration piece for everyone, and the greenish part is the rigorous piece. Now I want to show you in which data which role works, just so that you can get a sense of how this goes down. So first we have the inventor. That's the researcher. Research data scientist, research statistician, AI person. They tend to work in benchmark data sets. They're not solving real problems, they're working with toy data where the results are understood, where we know how that data performs, and we're seeing if we can make a microwave that performs better. It's like everyone has the same egg, let's see whose microwave works best on this egg. Then, the toolmaker also tends to work on toy data. So if you're going to make that cool microwave that everyone can use, you tend to also be working with benchmark data. Then we have the raw material supplier, that is the data engineer. That brings all the ingredients and usually is responsible for the splitting as well. The search engine, that is the basic analyst. That's where all the leader wants from them is something like, tell us the revenue numbers for last quarter. Produces facts from the data. Looks things up. That is a type of analyst, but there is another type of analyst. The type that finds something worth pursuing, finds inspiration for the decision maker. And this person's job is a lot like a prospector for minerals or oil. Do we know that we are for sure going to find some gold in this area? No. So can we be held responsible in advance for what we're going to find in this area? Also no. The right way to manage these folks is to say, here is your area that you get to work in, those data sets. Here is the amount of time I'm giving you. Now go do your best. If you don't have a no-strings-attached culture of analytics, you're not going to do well at finding the right rabbit holes for your experts to go down later. You cannot hold your analysts accountable in advance for what they're going to find. You need to have the guts to say, I'm investing time in analytics. You get 2 weeks on those data sets, go. Maybe they come back with something, maybe they don't. Very few companies have the guts to do that. And as a result, very few cultures can take advantage of analytics. That's a quick fix as well that you can think about as leaders. Then the decision supporter, the statistics team. The leader has figured out that some inspiration is worth pursuing, you go and you do this statistical analysis on the final data set. A mistake that you might make here is to usurp the decision role. You are carrying out what the decision maker, who works in between those two, has told you to do. Don't usurp that role unless it was delegated to you. It is the decision maker who frames your analysis for you. Then the decision maker is the one who looks at all this inspiration and decides what is worth pursuing rigorously. This person has to have business skills, has to understand your business environment. And then the automator, that's the machine learning person. If the decision maker wants to use data for repeated decisions or automation, then you're going to go back and you're going to poke around in that inspirational data and make it work. That's your goal. Turn it into a model or recipe that does the job. Then there's the information artist who visualizes data, who thinks about communicating things in a way that the human mind can take those facts in. That's non-trivial. And then there is the rare unicorn that is the all-in-one. These exist, but they are very, very rare. But there is a myth that it's every data scientist. Having seen these different roles, I hope you recognize just how different all the skills are. It would be ridiculous to expect your data scientist to be all of these. The coding styles between a data engineer, a machine learning engineer, and an analyst are completely different coding styles. You want one person to code with 3 different personalities, that's already split personalities. Now you want an analyst to also be a statistician. One goes very slow, one goes very fast. Whoa, that's too big of an ask. And yet, there's so much messaging in the industry that makes it sound like this is what data scientists have to be. You're not a real data scientist unless you're all of them. And then all these poor data scientists, they have this virulent impostor syndrome as a result. I just want to tell you all, it's okay, calm down. No reasonable grown-up can expect you to be all these things. Pick one, and be good at that one. Whichever one of these you pick, you are a super valuable member of the community. And focus on that one thing. Know what you're good at. And have fun with data science. Thanks, that's everything from me.